Hello and welcome to this video. In this video, we will go through the pattern matching section of PostgreSQL documentation. Last two videos, we have seen the example of regular expressions. So we'll go through the theory and see what PostgreSQL gives us. So if you have not watched my two previous videos, I would recommend that you go and watch those. We will try to go fast, but I think it will take probably two videos to go through the pattern matching theory because it's 15 odd pages. I think, let me see. So it is roughly 19 pages. Definitely going to take 2 to 3 days. So let's start. There are three separate approaches to pattern matching provided by PostgreSQL: the traditional SQL-like operator, which you might know, the more recent similar to operator added in SQL 1999, and POSIX style regular expressions. Aside from the basic does this string match this pattern, operators functions are available to extract or replace matching substrings and to split a string at matching locations. If you have pattern matching needs that go beyond this, consider writing a user-defined function in Perl or TCL. Caution. While most regular expression matches can be executed very quickly, regular expression can be configured that take arbitrary amounts of time and memory to process. Be wary of accepting regular expression search patterns from hostile sources. If you must do so, it is advisable to impose a statement timeout. Searches using similar to patterns have the same security hazards, since similar to provides many of the same capabilities as the POSIX style regular expressions. Like searches being much similar than the other two options are safer to use with possibly hostile pattern sources. Similar to and POSIX style regular expressions do not support non-deterministic collations. If required, use like or apply a different collation to the expression to work around this limitation. So how does like work is you take a string, you take like, and you do pattern. And string not like, and then you give pattern. The like expression returns true if the string matches the supplied pattern. As expected, the not like expression returns false if like returns true, and vice versa. An equivalent expression is not string like pattern. If pattern does not contain percent signs or underscores, then the pattern only represents the string itself. In that case, like acts like the equal operator. An underscore in pattern stands for matches any single character. A percent sign matches any sequence of 0 or more characters. So some examples are here. ABC like ABC, which is true. ABC like A percentage, which is true. ABC like underscore B underscore, which is true. ABC like C is false. Like pattern matching supports non-deterministic collations, such as case insensitive collations or collations that say ignore punctuation. So with the case insensitive collation, one could have capital A, B, capital C, like ABC, collate case insensitive, or capital A, small b, capital C, like A percentage, collate case insensitive. Both will result in true. With collations that ignore certain characters or in general that consider strings of different lengths equal, the semantics can become a bit more complicated. Consider these examples. Dot foo, dot like foo, collate, ignore punctuation. IGN punctive means ignore punctuation, which will be true because we are ignoring dot. And then dot foo, dot like, f underscore o, collate, ignore punctuation will also be true. Dot foo, dot like underscore oo, collate, ignore punctuation will be false because dot will match, underscore will match with dot. The way the matching works is that the pattern is partitioned into sequences of wildcards and non-wildcard strings, wildcards being underscore and percentage. For example, the pattern f underscore o is partitioned into f underscore and o. The pattern underscore oo is partitioned into underscore and oo. The input string matches the pattern if it can be partitioned in such a way that the workloads match one character or any number of characters respectively, and the non-wildcard partitions are equal under the applicable collation. So, for example, dot foo dot like f underscore o collate ignore punctuation is true because one partition dot foo dot into dot f o dot and then dot f is equal to f. Collate ignore punctuation matches the underscore wildcard and o dot is equal to o. Collate ignore punctuation. But dot foo dot like underscore o collate ignore punctuation is false because dot foo dot can be partitioned in a way that the first character is any character and the rest of string compares equal to oo. Note that the single character wildcard always matches exactly one character independent of the collation. So in this example, the underscore would match dot, but then the rest of the input string won't match the rest of pattern. Like pattern matching always covers the entire string, therefore if it is desired to match a sequence anywhere within the string, the pattern must start and end with a percent sign. To match a literal underscore or a percent sign without matching other characters, the respective character in pattern must be preceded by the escape character. The default escape character is backslash, but a different one can be selected using the escape clause. To match the escape character itself, write two escape characters. If you have standard conforming strings turned off, any backslash you write in literal string constants will need to be doubled. It is also possible to select no escape character by writing escape empty string. This effectively disables the escape mechanism, which makes it impossible to turn off the special meaning of underscores and percent sign in the pattern. According to the SQL standard, omitting escape means there is no escape character rather than defaulting to a backslash, and a zero-length escape value is disallowed. PostgreSQL's behavior in this regard is therefore slightly non-standard. The keyword I like can be used instead of like to make the match case sensitive according to the active locale. But this does not support non-deterministic collations. This is not in the SQL standard, but in the PostgreSQL extension. The operator tilde tilde is equivalent to like, and tilde tilde star corresponds to I like. There are also exclamation mark tilde tilde and exclamation mark tilde tilde star operators that represent not like and not I like respectively. All of these operators are PostgreSQL specific. Now here is a piece of warning. Do not use PostgreSQL specific operators if you want to have the ability to change your database. For example, suppose you wrote some application which makes use of PostgreSQL, and later you want to change to something like MySQL or Oracle or DB2 or any other SQL database, then it will be problematic. So there are two main specifications. I have not talked about it. There are two main specifications, NC standard of SQL and ODBC. You stick to one, either NC or ODBC, and then all databases which will support that standard will be easily available to you. You may see these operator names in explain output and similar places, since the parser actually translates like et al. To these operators. The phrases like, I like, not like, and not I like are generally treated as operators in PostgreSQL syntax. For example, they can be used in expression operator any. Subquery constructs, although an escape clause cannot be included there. In some obscure cases, it may be necessary to use the underlying operator names instead. Also see the starts with operator, caret at the rate, and the corresponding starts with function, which are useful in cases where simply matching the beginning of a string is needed. Now we look at similar to regular expressions. So we have a string similar to pattern and then escape character, or string not similar to pattern. The similar to operator returns true or false depending on whether its pattern matches the given string. It is similar to like except that it interprets the pattern using the SQL standards definition of a regular expression. SQL regular expressions are a clear cross between like notation and common POSIX regular expression notation. Like and similar to operator succeeds only if its pattern matches the entire string. This is unlike common regular expression behavior where the pattern can match any part of the string. So this is something you have to take care of. Okay, the pattern must match the entire string. Also, like similar to user underscore and percentage as wildcard characters denoting any single character and any string respectively. These are comparable to dot and dot star in POSIX regular expression. In addition to these facilities borrowed from like similar to supports these pattern matching meta characters borrowed from POSIX regular expression. Type denotes alternation. Either of the two alternatives. We have already seen the meaning of these symbols in the video which I recorded in the last two videos. So we'll quickly skip this. We don't need this. So that's why I said in the beginning that if you have not watched the two videos prior to this one, then you should go ahead and watch those. As with like a backslash disable the special meaning of any of the meta characters. A different escape character can be specified with escape, or the escape capability can be disabled by writing escape empty string. According to the SQL standard, omitting escape means there is no escape character rather than defaulting to a backslash and zero length escape value is disallowed. PostgreSQL's behavior in this regard is therefore slightly non-standard. Another non-standard extension is that following the escape character with a letter or digit provides access to the escape sequences defined for POSIX regular expressions. Please give me 5 seconds. Sorry about that. So we have some examples here. ABC is similar to ABC, true. ABC is similar to A, false. ABC is similar to percentage B or D, percentage which will be true because percentage will match A and then B will match and then percentage will match D. This means either B or B, so it could match ADC as well. ABC is similar to parenthesis B or C percentage. So this will match B followed by any more characters, and C will be or C followed by any character, but it does not match the beginning of string A. Then we have minus ABC minus, similar to percentage backslash M ABC backslash capital M percentage. So this percentage will match minus backslash N ABC backslash capital M will match the word boundary of ABC, and then final percentage will match minus. Let's see then why this one does not match. It's because the word boundary means the ABC should be surrounded by non-alphanumeric characters, but we don't have that. We have basically X and Y alphabets, so it won't match. The substring function with 3 parameters provides extraction of a substring that matches an SQL. It should be read SQL because it is an, and we read this as SQL, that is the more popular pronunciation. So I will say SQL. Regular expression pattern, the function can be written according to standard SQL syntax. So we have substring, string, similar, pattern, escape character. So in general, we don't care about this. We will let the escape character to be default. Backslash. So string, similar, pattern. Or using the now obsolete SQL 1999 syntax, substring string from pattern for escape character. Or as the plain 3-argument function, substring string pattern escape character. As with similar to, the specified pattern must match the entire data string or else the function fails and returns null. To indicate the part of the pattern for which the matching data substring is of interest, the pattern should contain 2 occurrences of the escape character followed by a double quote. The text matching the portion of the pattern between these separators will return when the match is successful. The escape double quote separators actually divides substance pattern into three independent regular expressions. For example, a vertical bar in any of the three sections affect only one section, only that section. Also, the first and third of these regular expressions are defined to match the smallest possible amount of text, not the largest, when there is any ambiguity about how much of the data string matches with pattern. In POSIX parlance, the first and third regular expressions are forced to be non-greedy. As an extension to the SQL standard, PostgreSQL allows there to be just one escape double quote separator, in which case the third regular expression is taken as empty, or no separators, in which case the first and third regular expressions are taken as empty. Some examples with hash delimiting the return string. So we have foo similar, percentage hash double quote, q and o underscore b hash double quote, and then we have percentage. So it will match OOB. Our escape character is hash. So let's see how this works. So we have foo here, okay? So percentage will match F, all right? And then we have double quote, all right? So if you see this, there was the test escape as an extension to the SQL standard. PostgreSQL allowed there to be one escape double quote separator. So it's a separator, okay? And then we have O underscore B, which will match OOB. And then we have the separator and percentage. So the last percentage will match AR. So this is basically OOB. And similarly, you can understand why this does not work. Okay, there is no percentage here to match the F or AR. So now we look at POSIX regular expressions. So most of it, again, we have covered. Okay. So this dot star meaning and everything. So text, we have already seen this. Text match will give Boolean. Text non-match will case insensitive match will give Boolean. Text and not match will give Boolean. Text and text does not match will give Boolean as well. POSIX regular expressions provide a more powerful means for pattern matching than the like and similar to operators. Many Unix tools such as wget, sed, or awk use a pattern matching language that is similar to one described here. A regular expression is a character sequence that is an abbreviated definition of a set of strings, a regular set. A string is said to match a regular expression if it is a member of the regular set described by the regular expression. As with like, pattern characters match string characters exactly unless they are special characters in the regular expression language. But regular expressions use different special characters than like does. Unlike like patterns, the regular expression is allowed to match anywhere within the string unless the regular expression is explicitly entered to the beginning and end of string. So ABCD will match BC here because you don't have to match the full string. ABCD will match A.C because dot will match B here. Dot matches any character. So these examples I will not go through. We have already covered in previous videos. The POSIX pattern language is described in much greater detail below. Let's see how much we have. Quite a bit. So we can't cover that much. So we will stop here. And in the next video, we'll start from the description of POSIX pattern language or regex language. So we stop here, and I hope that you have found this video useful and informative. And I will once again say that watch the previous two videos. There is a lot of information there about POSIX expressions. This video, we have explored like and similar to and how like and similar to work. So I hope that you have found this video useful, and in tomorrow's video we will continue reading the POSIX language. Most of it is covered already in previous two videos, so we'll just do a quick read through of this, and then we will go and look at table expression details. and other things. So most of it we have already covered, all right? But certain things we have not covered. For example, these character entry skips we have not covered, so we'll go through this. As I said, it will, sorry, give me a moment. Okay, so what I'm looking at is when the next section starts. This is all regular expressions, regular expressions. Okay, so next section starts with, all right, yeah, okay, data type formatting function. So we are quite far away from that. It will take probably 3 days, at least 3 more days to cover this. So no worries, slowly and surely we will get there. So I thank you for watching the video, and I hope that you have enjoyed this video as well as you are enjoying the playlist. And we will continue to explore PostgreSQL in quite a bit of depth. And I will also prepare some examples of like and similar to. Basically, they are very simple. You have to just manage percentage and underscore. There is no magic there. So I'll stop this video here, and once again, thanks a lot for watching the video. We will meet tomorrow with another video, and till then, I'll take my leave and take care and enjoy.